Hello everyone, welcome to SIG Autoscaling weekly meeting for Monday the 20th of May 2024. We have a few items already on the agenda. Any updates beyond the ones last week? Just first of all, is there someone able to take notes this week?
I can do that.
Thanks. Awesome. Cool. Is there anything in terms of updates on the test grid at the moment? We had a bit of discussion about this last week, but just double check.
I think one update is a lot of the old cluster autoscaler tests relied on cloud provider GCE being in tree. And now that it's not, they are very much not passing. So we're still figuring out how to deal with this. Ideally, we probably want to re-implement some of those or most of those into a provider agnostic test. That probably is not going to work for all the tests because some of them would be very hard without the direct ability to add or remove VMs underneath, which is not supported by the generic framework, it seems. But at least I think the way forward that we're considering is mostly let's just re-implement the tests that we can. The alternative is migrating the GCP test to test provider GCP out of tree, but there is still some work there being done to set up test environment, and so it's unclear how quick that way is. We basically would have to take a dependency on people doing this, and those are currently the options, and we're kind of considering them. So I'd say it's still going to take a few weeks, but it's being worked on, and maybe we can move it from weekly agenda item until we fix it, because I'm getting very similar updates every week.
Yeah, cool. Yeah, makes sense. Okay, so Sarabu.
Hi, Guy. How are you? This is a follow from the last week. We have submitted the PR. I hope David is also joined the call. So he did get a chance to review and he raised a few questions. David, do you wanna go ahead and talk about the PR, which is 6818, I think, in this case?
Sorry, I'm a bit confused as we have. So the first item on the agenda is the plans to support HA.
Oh, sorry about that. I was talking about the next item in the list. So let me start in the order. The first item on the list is about HPA. It is about VPA. So there are three components to it: the recommender, updater, and admission controller. So we went through the code, and we are using. Actually, we intend to use VPA at scale, where we have like millions of pods in our cluster. Right? So the intention was if we can have a feature to be able to run VPA with multiple instances of recommender, updater, and admission controller. It's about that. So we created an incident 6846 requesting to enhance the feature to be able to run VPA with multiple instances. Any feedback would be really appreciated. How we can take the approach forward. Is it feasible or is it constrained?
I think I'm not the biggest expert in the VPA, but I think there's going to be issues there, at least with the updater. From what I know. I'm not sure if I don't think we've got any of the more experienced maintainers of the VPA on the call who would maybe want to weigh in. Otherwise, it's going to be one for getting feedback on the issue as to whether or not that's feasible.
Thanks, Guy. I mean, the intention is, we opened, there's a placeholder already, right, for this instance.
Yeah.
Perhaps we can take the discussion forward in the PR and we can discuss about, the intention is, yes, updater, we need to have a distributed consensus mechanism to serialize updates so that we would not run into any race condition, right? So, I mean, what would be the best approach we can take forward? And we can start perhaps, enhancing the code once we agree upon the way forward, right? That's the help we are looking for. Basically, if we all agree that, okay, you know what, this is the best way forward to implement multiple instances of VPA, then we will take that approach and we'll start coding. So what we need help from all of you is please do participate in the discussion and let us know what's the best way forward to scale VPA in this case.
I think from a first pass over the issue, I think it would be good to have a bit more detail on where you see issues, like what scale is it happening, what are the actual issues you're seeing, because the issue at the moment sort of says you can get things into crash loop back off or bad states after a new release or node patching. I think we need a bit more clarity on like what are the failure states that we're seeing here, and what are we trying to address with this potential work.
I mean, we are going to do stress test, Guy, with the millions of parts. But what we are looking at is the resiliency perspective and scaling perspective. When we are running, the cluster with a large number of worker nodes, large number of parts. When I say, think like, about 2,000 plus worker nodes, millions of parts running in my cluster, would VPA able to handle that workload? So from resilience perspective, would it be able to, I mean, at that scale, would it be able to provide proper recommendations, etc., right? So the intention is if we can horizontally scale VPA control plane itself by having multiple recommender instances, multiple updater instances, multiple admission controller instances, each sharing a portion of workload, and that way we can scale it out horizontally, right? That was the intention. But at this point, I cannot per se, I mean, we haven't done VPA through the stress testing, but we will definitely let you know. But at very high level, if we were to scale horizontally, what would be the approach we should be taking for VPA? When I went through
I guess to me it sounds like you have a good idea of what your concerns are at the moment, and it doesn't seem like that detail is in the issue. And I think that detail would be good to have across in the issue for follow-up discussion.
Sure.
I think addressing that, like addressing a concern of VPA, updater going unavailable for the whole cluster is may have a different approach to we want to horizontally shard it such that we've got a higher throughput.
Absolutely. Thank you, Guy, for the feedback. We will add those data points to the instant.
So if I may, I was quite curious about the, because for scalability and horizontal scaling, what is the desired scale? For context, I just checked, and the official Kubernetes documentation lists 150,000 pods as the maximum supported by Kubernetes. So do we want to go higher than that? It's a question why Kubernetes lists this as a limit. What else can blow up on the way? That seems like pretty significant change. So it would be good to define, I think, what the goal is and how we're going to test it. And then from there, I think it's much easier discussion in terms of how we get there.
Absolutely, agree with you. So let's put to we'll put those data points part of the incident, and that will act as our baseline when we take the discussion forward.
Awesome. I think Anush. Sorry if I'm. Is that how you pronounce your name?
Yeah, that's correct. I think maybe the other thought perspective is I work with Krishna is that even if it is not horizontally scalable, I think if there is high availability around these recommenders of data, that will really be helpful. So if one goes down, the other comes up because there is a state component to it. So if there is even high availability, then that will really help out. Yeah, that's all from my end.
Okay, cool. Yeah, agreed.
Thank you.
Lee? We can't. Well, I can't hear you.
Sorry, can you hear me?
Yep.
Yep. So yeah, I think our main issue here is availability, right? In terms of scale, we have thousands of clusters, right? So it will be very hard to operate each VPA and monitor those across the fleet. So if we do have high availability, will help us to it will make our life a lot easier.
Okay. Cool. Yeah, understood. Thanks. David, discussion of 5829 and 6818.
Again, this is with the David.
Sorry, just muted. Yeah, I think there's been a couple of discussions about this already, which I missed. So sorry if I'm rehashing anything. I think for context, the issue here is that AWS can get into a state where it doesn't have instances available when Cluster Autoscaler tries to scale up. And I think, don't remember, a year or a year and a half ago, I put in a feature that will try to detect if AWS is in that state and early abort. So it will just stop trying to scale up that node group and pick something different. And I guess what happens here is that sometimes it will partially scale up, but it isn't able to completely fulfill the request. And then in between when it scales up and when Cluster Autoscaler tries to do something else, it changes the size of the ASG, which then can cause some actual nodes in the cluster to get terminated when they shouldn't have. I think so if I understood the proposed fix correctly, we were just making an additional API request to AWS before we changed the ASG size. And if at that point, if we had seen scaling behavior for the ASG, then I think we just skipped the scale down. We didn't readjust the ASG size back down. And I guess I'm kind of nervous about that approach. I'm not convinced that it actually still solves the problem. Because the way that we scale the ASG down one at a time, and so you make this API request to see if there's been recent scaling, and then there's still possibility for a race condition there, where as you're scaling down, removing these placeholder instances one at a time, you could still end up in a situation where the ASG is scaled up, and then you have the same problem. So I guess, does it make it less likely? Yes. You could make it even more, you can make it even less likely by checking that API during every iteration of that loop, but then you're going to have a huge burst of API calls, which seems not great. but I'm not convinced that this is actually going to solve the problem, I guess is the short answer here.
Thank you, David, for the feedback. This is Krishna. What I see here is cluster autoscaler, the cache of ASG maintaining its own state versus autoscaling group from cloud provider itself maintaining a different state of ASG, right? Mm-hmm. So the way the current logic is happening based on my understanding is that it is maintaining the state and going into a loop with the sleep time, based on the configuration. In our case, it's about 50 seconds. And when it comes back after 50 seconds, then simply it's going through the placeholder instances, presuming that these placeholder instances were putting cluster autoscaler cache because of the node provision failure by the provider, right? So simply it's going to go into the loop and scaling down, and that's causing the intermittent failures, like you explained. So the only way, what I was thinking, was to resynchronizing the state of local cache at the beginning of the loop. That's one way to look at solving the problem, right? And there's always a race condition, like you said, right? Even after resynchronization, and before I come back and terminating my node, there might be a case where at lightning speed node might have been provisioned. Unfortunately, what we are that we cannot control, I guess, unless we have a event that can alert cluster autoscaler if something happened, and we could take an action. But in this case, these are all two independent mechanisms, and the only way I think we can maintain the state and synchronizing it at the beginning of the loop iteration. And the way we try to approach to this problem in this particular case, in this particular PR, is at the time of taking an action, we are looking at the scaling activity, right? So if the activity is a failure, no questions asked, no harm is done, right? And if the activity is success, that means whatever you requested, all provisioned, no harm is done in this case either, right? Based on the current logic. The only problem, like you explained, is a partial success, what I see, right? You requested for 5 nodes, 2 provisioned, 3 not, for example, right? So in that case, maybe rather than going through the loop iteration every time, checking a scaling activity, maybe what we were thinking of is take a step back, look at the node counts that are provisioned by ASG, just make one API call. Look at the really provisioned nodes, the current state of ASG, a cluster provider, and look back at our cache. How many of them are real nodes? How many of them are placeholder nodes? Perhaps remapping the placeholder nodes to the recently provisioned nodes, and then take an action of scale down on the remaining placeholder nodes, maybe is a way to less likely run into this problem. What do you think, David, by taking this approach to handle partial success scenario?
Masiak, I see you have your hand up.
Sure. So I feel I don't know enough.
Apologies. I'm really apologize. I just wanted to add one more thing. In the logic, right? If you notice, David, we are trying to resynchronize cache, right? Mm-hmm. If we see if it is a partial success, if it is a full success, right, by cloud provider, but our ASG cache is out of sync, so we are resynchronizing the cache to make sure it represents in ASG cache of cluster autoscaler. I just wanted to add that data point.
Sure.
So I don't know the ASG API of the top of my head well enough, or the implementation of AWS provider, but I think for exactly the same issue, the way we handle it in GCP provider is essentially there is a cloud provider.refresh function call done by cluster autoscaler at the start of every loop. And so there is essentially a guarantee that when this is provided, like after this call and before deleting any nodes that fail to start up, there is not going to be any new nodes added, because the scale up happens later in autoscaler loop, and it's all synchronous and single threaded. So what we do is essentially, if you at this point called target size. They get the target size of ASG and then get a list of instances within ASG, assuming like I'd imagine there would be some ways like in terms of ASG API to do those two things. You could at that point easily, I think, calculate the delta between the two, and then that would be the number of placeholders you essentially have at that point, and that shouldn't change between that moment and the delete call. Does that make sense, or is it just complete?
So you're right on the track, right? There is, I mean, there is a parameter called refresh interval. I have seen that, right? And in our case, the refresh interval by default is set to a minute in cluster autoscaler, right? Which is refreshing cache. And whereas my loop interval is about 50 seconds, right? Or 30 seconds, depending on what I configure, right? So in this case, if I force refresh interval for every loop, so then we make this refresh interval parameter obsolete completely. And during the beginning of the loop, you refresh the cache and you represent what's out there in cloud provider versus what's there in your cache, then take actions based on it. I agree with you. That logic works perfectly. If that's what GCP is doing, then perhaps we should adopt the same logic for AWS as well. But
so I think the problem here, it sounds like GCP, so I'm not familiar with GCP, but it sounds like GPC is entirely synchronous. AWS unfortunately does not have that behavior. You make a API called increase the size of the ASG. It reports success regardless of whether it's able to provision nodes or not. And then later on, you discover whether it's actually able to provision those nodes. And so you end up with this sort of unavoidable race condition here. I think my proposal, which I mentioned in the comment thread and also in the chat, you can set on AWS scale in protection on your ASGs, which basically you can change the desired size of the ASG down, but it will not terminate any instances for you. You actually have to go in and detach, and there's an atomic API call where you can detach and remove the size, change the size of the ASG. I don't remember. I need to go look at the cluster autoscaler code. I don't remember if that's going to work well for the AWS cloud provider or not. But I think one of the things I wanted to see here is if anybody knows off the top of their head whether that approach would work.
Regarding the scaling of production, David, I would like to add a point. Thanks for the feedback and again helping us here. I mean, the way we operate at scale, unfortunately, we cannot adapt that workaround. So that's one of the workaround that was suggested in 5829. It really back like about 2 months back. But we went back and unfortunately that workaround we cannot use at the scale we are using EKS. So having said that, right, what we are looking at is a code fix that can help us either reduce the occurrences or completely avoid this particular bug.
I'd be interested as to why you can't use that at scale. My other concern here is we do have one more item on the agenda, and it is slightly time sensitive. So I just want to squeeze that in. But Maciek, if you've got one more.
I had similar comment. I think this is obviously going into in-depth technical discussion, which feels like we don't really have time to get to the bottom of this. Would it make sense to just have a meeting maybe next week, just dedicated to this? I'm not talking SIG meeting, but like, let's say, set aside a slot, maybe just immediately after SIG meeting, and so that all the interested people could join, and we can have more in-depth discussion of this specific question.
Yeah, that sounds great to me.
Yeah, sounds good to me too. Thank you.
Thanks.
I think the last item was mine. I'll go quick. I'm trying to put together a panel discussion for KubeCon comparing cluster autoscaler and Carpenter. I've done some like data analysis on the two, and I think Almiko has also done some analysis here. I would really like to have a bunch of different people who have maybe looked at this question, because I think that the two different approaches are going to be like what's better is different for everybody. So I'm just trying to see if there's any interest. I think since we're out of time for the meeting, ping me on Slack if you're interested in participating. I think the one thing we need to be aware of is there are diversity requirements for a panel discussion. And so that's one thing I'm trying to also navigate. But I'm DR more on the Kubernetes Slack and the CNCF Slack. So
Awesome. Thanks very much. That was all we had on the agenda, and we've hit time for this week. Thanks very much. Should we start a just discussion in the SIG Autoscaling channel to arrange to try and schedule something for next week on that AWS issue?
yeah, sounds great.
I'll check. All right.
Thanks all.
Thank you all.
Thanks very much. See you all next week.